In this video, we will look at special types of factoring. Before we start, I just want to run over a list of all the perfect squares to 169. Of course, this list is infinite, but 1 squared is 1, 2 squared is 4. We have 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and of course this keeps going. So to factor the difference of two perfect squares, that's two perfect squares with a minus in the middle, you take the square root of the first term, so that goes here and here, a and a. The square root of b squared is b and b, and then your signs are plus and minus. Also, the sum of two squares is always prime. It can never be factored. So if you see the sum of two perfect squares, you can automatically put that it's prime. Let's factor y squared minus 25. So make two sets of parentheses. The square root of y squared is y, and the square root of 25 is 5. And then your signs are plus and minus. By the way, to take the square root of a variable with an exponent, you divide the exponent by 2. Let's factor 49s squared minus 4t to the 4th power. The square root of 49 is 7, and the square root of s squared is s. So I have 7s times 7s. The square root of 4 is 2, and the square root of t to the 4th power is t squared. Remember, you divide the exponent by 2. And then your signs are plus and minus. 7s plus 2t squared times 7s minus 2t squared. Another special type of factoring is factoring a perfect square trinomial. You can tell it's a perfect square trinomial by seeing that the first and last terms are perfect squares, and the middle term is twice the product of the square roots of the first and last terms. And so to factor this, you just take the square root of the first term, the square root of the last term. This sign matches the first sign. So if you have a minus, then you put a minus here. And then this binomial is squared. So if I multiply this binomial by itself, then I get the perfect square trinomial. So let's look at x squared plus 14x plus 49. You first want to check to see if this is a perfect square trinomial. The first and last terms are perfect squares. The square root of x squared is x, and the square root of 49 is 7. And if I multiply 7x times 2, I get 14x. That's the middle term. So to factor, you take the square root of x squared, which is x, the square root of 49, which is 7. This sign matches the first sign, so it's plus. And then this binomial is squared. X plus 7 times x plus 7. If we do the first, outers, inners, and last, then we get x squared plus 14x plus 49. The last special type of factoring is the sum and difference of two cubes. And so you want to utilize these formulas. So you can take the cube root of 1, it's just 1. The cube root of 8 is 2. The cube root of 27 is 3. I'll just write them off here to the left. So the perfect cube and then the cube root. 64, the cube root is 4. 5 to the third is 125, so the cube root of 125 is 5. And the cube root of 216 is 6. And that's as far as we're going to go with these. Of course, they do keep going. So if we have the difference of two cubes, and by the way, to take the cube root of an exponent, of a variable, you divide the exponent by 3. So the cube root of a cubed minus b cubed goes here and here, a and b. Then you square the a, you multiply a times b, and then you square the b. The sum of two cube formula is just the same, except these signs are switched. And how I always remember it is this first sign always matches the one in the original problem. Let's try one. We're going to factor w to the third power plus 64. And I've already written down the formula for factoring the sum of two perfect cubes. So in the first set of parentheses, we want to take the cube root of each term. The cube root of w to the third is w, and the cube root of 64 is 4. Now to get what goes in the second parentheses, you square the first term, so that would give me w squared. Then I put minus. You multiply a times b, so w times 4 is 4w. And then we square the last term. 4 squared is 16. Please don't hesitate to contact your instructor with any questions that you have.